Hey everyone. In our last video, we learned how to write equations in slope-intercept form. And if you remember, slope-intercept form looked like this. Y equals mx plus b, where y and x, remember, are just any two coordinates. So x and y coordinate is what this and this are. And if you remember, m is our slope and b is our y-intercept. And we know what slope is, right? Slope is just rise divided by run. And our y-intercept, well, that's where the line crosses the y-axis, right? So what we're looking at today is writing equations for lines in slope-intercept form like this. Now, the first thing is any two-variable equation with an x and a y, we can write in slope-intercept form. So here's what I mean by that. Let's get ourselves some more space here. So any equation that we have, for example, it could be something like here it could be something like 5x plus 4y equals 8. Now, this is not written in slope-intercept form, right? Slope-intercept form looks like this. Y equals mx plus b. So if that's the case, we want to get y completely by itself like it is over here. And we want our x and the coefficient that goes with x to be right here, mx, on the other side of the equation. And then we want our number without a variable, our b, to be over here on the end. So we need to solve this equation in terms of y. And we learned how to do that in our previous unit, how to solve it for one variable in terms of another. In this case, we just want to solve this equation for y. So in order to do that, what we need to do is we need to make this 5x disappear from the left side of the equation. And to do that, we take away 5x. And if we've taken away 5x from one side of the equation, we need to do it to the other side of the equation too. Let me make a better x there. So what you'll notice is if this appears to be our b, as it stands right now, right? It doesn't have any variable with it. So that's our b. It doesn't have the x or the y with it. We want that on the very far end of the equation. So I like to take this minus 5x and just slip it in right here in front of the 8. And since this is a positive 8, I'm going to say negative 5x plus 8 instead of saying 8 minus negative 5x. So this cancels off right here, and I'm left with 4y on the left side, and that's equal to, like I said, I'm going to slip in this negative 5x, and then since we had a positive 8, we're going to write plus 8. Now I'm pretty close to there. You'll notice here that I have my y is in the right spot. You'll notice that my mx is now in the right spot, and you'll notice that my b is in the right spot. But if you look up here, this doesn't say 4y, it says y, right? So in order to get y by itself, we need to get rid of this 4. So right now this is y times 4. We want to get rid of 4 by doing the opposite. So we're going to divide by 4 over here and get that 4 to cancel out. If we do it to one side of the equation, we need to do it to the other side of the equation. And with division, we have to do it to every term on the other side of the equation. So that means this needs to be divided by 4, and this needs to be divided by 4. So now we're left with y equals, and we have a negative 5x divided by 4, or I could say negative 5 over 4x, plus 8 divided by 4, which is 2. So now I've written my equation in slope-intercept form. And we can see here that I have a slope of negative 5 over 4, and I have a y-intercept of 2. So this would be a really easy equation to graph now. Or the other reason we sometimes like to put these in slope-intercept form is if you have two equations that you're looking at, you can very quickly compare them, see which one has a larger or a smaller slope, see where their y-intercepts are. So it's a good way to compare two equations and have them in the same format. Let's try another one of these. Let's get some more space over here, and we'll do, on this one, we'll do 2x minus 3y equals 7. So remember, I want to get this written in the form y equals mx plus b. And so our mx is going to be our 2x right now. Our y at the moment here is negative 3y, and our b at the moment is just 7. So we're going to rearrange this, and we want to get y by itself. So in order to do that, we need to get rid of this 2x first. Oops. We need to get rid of this 2x here first. And so in order to get rid of this 2x, I'm going to take away 2x. We'll cancel that out. If I do it to one side, I have to do it to the other. Remember, I like to take this and slip it just after the equals sign so that it's in the right position for y equals mx plus b. So I'll rewrite this equation now as negative 3y on the left is equal to, and I'll say negative 2x. And now since this is a positive 7, I'm going to write plus 7. Now I'm very, very close, right? I have my y in the right spot, I have my mx in the right spot, and I have my b in the right spot. The only thing I need to do is get rid of this negative 3 in front of y. And so in order to do that, I divide by negative 3 to cancel that out. But if I do something to one side, I have to do it to the other. And if it's division, I have to do it to every term. So I'm going to divide this by negative 3 and this by negative 3. And I'm left with y is equal to negative 2 divided by negative 3, which is just 2 over 3, but the negatives cancel each other out. So I have 2/3 x plus 7 divided by negative 3 is 2 1/3, right? Or we could just leave it as negative 7 over 3, right? 7 over 3, but we have a negative sign on the bottom, so our answer is going to be negative. So I could say negative 7 over 3. Or I could rewrite this as y equals 2/3 x. And instead of plus negative 7 over 3, I could just write minus 7 over 3. This would be our final answer here. We have our y-intercept that doesn't divide evenly, and we have our slope here, 2/3. All right, let's do another one of these. Let me make some more space here. Actually, let's look at this. We can compare these two equations that we just found. So we could see which one has a larger slope. The one with the larger slope is this one here, because it's not negative, right? 2/3 is larger than negative 5/4. So that has a larger slope. Although if we were to look at which one has a steeper slope, the steeper slope would be the higher magnitude. We're not then caring if it's negative or positive, because remember, when we have a coordinate plane, we know that our negative lines go down like this from left to right, right? But when we have a coordinate plane, our positive lines go up like this from left to right. And the negative versus the positive doesn't matter so much. When we're talking about steepness of a line, it just says which direction it goes. Is it losing or is it gaining? And so if we were talking about which one of these slopes is steeper, in that case, this one here would be steeper because negative 5/4 has a steeper magnitude, right? 5/4 is steeper than 2/3. 5/4 is greater than 1. 2/3 is not. So that one would have a greater slope, or a steeper slope, we could say. Let's do another one here. Oops. All right, let's try 5y minus x equals 15. So remember, we want to make this a little bigger here. We want to get y equals mx plus b. And so our x is on the wrong side of the equation right now. Right now we have a negative x, and we want to get rid of that to the other side. So I'm going to start out by doing a plus x. Minus x plus x cancels out. If I do it to one side, I have to do it to the other side. This is like a 1x, right? We could call this 1x instead of just x. So we now have 5y on the left side. Remember, I like to take this and plug it in right here after the equal sign. So I have 1x, and this is a positive 15, so I'm going to write plus 15. And now all I need to do is get y by itself. I'm going to do this by dividing by 5 to each term on both sides of the equation. 5 divided by 5 cancels out, and I'm left with y equals, and I have 1/5, 1 over 5, x, plus 15 divided by 5 is 3. So we can see our slope and our y-intercept. Good. Let's try one more of these, and I'll put it up here, and I want you to give it a try, so you can pause and give this one a try on your own and see how you do with it and compare it to my answer then. So let's try this one here. Let's do 2y minus 3x is equal to negative 4. And remember, you want to get it in the form of y equals mx plus b. All right, so go ahead and pause and try to solve this one for y in terms of x and put it into slope-intercept form, and then we'll compare with mine in a second. So go ahead and pause. Do it now. All right, I'm going to assume that you tried this one already. Let's answer it together. We know that we need to get this negative 3x away from the left side of the equation because we just want y there. So we're going to do the opposite. We're going to add 3x and get that to cancel out. If we do it to one side, we have to do it to the other side. So now I'm left with 2y is equal to, remember, we like to plug this in first, so 3x, and then I have a negative 4 up here, so we're going to write minus 4. And then the last thing I need to do is just get rid of this 2 that's next to the y. And I do that by dividing. And if I divide on one side, I have to do it to the other side, but I have to do it to every term on the other side. That's different than addition, right? Addition, we would just add on to the end. But division, we have to do divided by 2 and divided by 2. That cancels out, so I'm left with y equals 3 over 2x minus 4 divided by 2 is 2. Did you get that answer? Go ahead and compare to mine. Now, writing an equation for a line in the form of y equals mx plus b, right? Let's say we want to write y equals mx plus b. This is pretty easy if someone were to give you a slope and a y-intercept, right? If someone were to say the slope is equal to 1 over 2 and the y-intercept is equal to 5, well, that's pretty easy. We know that the slope is m, and we know that the y-intercept is b, and we know that we just leave x and y as variables. So it's very easy to go in here and just say, okay, this would be y is equal to, instead of m, I'm going to write 1/2 x, and then instead of b, I'm going to write 5, so plus 5. And that's super simple to do, right? But what if you didn't know either the slope or the y-intercept? So for example, what if you had one that you were going to write as y equals mx plus b, and we know that we always need to know the slope and the y-intercept. And we know that these also contain an x and a y, that these are the ones here that we care about, but we know that there's also an x and a y in each of these, right? Now, if it gives us the slope and the y-intercept, that's super easy. What if this one said that we had a slope of 4, and we didn't know the y-intercept, but we did know that this line passes through the point, let's say 2, 6. Well, we know that this has a slope of 4, right? The problem told us that. We don't have a y-intercept. We need a y-intercept in order to be able to write this equation. But what we do have is a coordinate. And we know that a coordinate is an x, y, right? So what that tells us here is that we actually have an x, right? Our x is 2, and we have a y. Our y is 6. So I could plug in here x equals 2. Oops, let me stick with black here. X equals 2. And I could say that y equals 6. Now, we don't care about the x and the y when we actually write our equation. But if we know that the x and the y stand for any coordinate pair that makes this line true or that falls on this line, well, then we could use those. We now know out of these 4 things here, slope, y-intercept, x, and y, we now know 3 of the 4. And what that means is if we were to plug all of these into our equation, we've created a one-variable equation, and we know we can solve a one-variable equation. So let's say that, let's see here, 4 is my slope, and 2 is my x, and 6 is my y. Well, I could just rewrite this then as, instead of y equals, I'm going to write 6 equals, and instead of m, I'm going to write the slope of 4. And now this is m times x. When two variables are up against each other like that, it's multiplication. So I can't just write a 2 after this. I can't put 2 in for x like this, because that says 42. And that's not what this means. It doesn't just put the digits next to each other and make a new number. This is 4 times 2. So the way that I write that is I put the x in parentheses, so that a number up against parentheses is multiplication. So I have 6 equals 4 times 2 plus b. Now, I don't have a b, and so I just have to leave that as b. But what I do have now is just a one-variable equation, and we've solved tons and tons of these one-variable equations at this point. So we know how to make really fast work of this. We're just going to carry out the math. So we have 6 equals 4 times 2 is 8 plus b. We want to get b by itself, which means we have to get rid of this 8. So we're going to get rid of that positive 8 by subtracting it. We'll go minus 8 here. If we do it to one side, we need to do it to the other side. So minus 8. This cancels off, and I have 6 minus 8, which is negative 2, and that's equal to b. So we've now found a solution for b, right? b equals negative 2. So I can go up here and I can write the y-intercept is negative 2. Now, we actually don't care anymore about this x and y. That's not going to make its way into our final answer, right? We just use those digits because they gave it to us down here, whoever they is. I guess they was me this time. But when you get a problem, if it gives you a coordinate like that and you don't have a slope or a y-intercept, you can use those to find what you need. Now that we have what we need, we're going to write our equation in slope-intercept form, but we're going to do it by leaving y and x just as variables. So let's rewrite our equation here. So our equation is y equals, and our slope is 4, so 4x, we'll leave x as it is, plus b. Our b is negative 2, so we're going to write minus 2. And there's our equation in slope-intercept form. Y equals 4x minus 2. Has a slope of 4, and it crosses the y-axis at negative 2. Let's try another one of those. And oops, and this time, let's go over here. This time, let's give us a y-intercept, but I won't give us a slope. So let me think here. So let's say we had this problem. All right, so I popped a question in here. We have a question that says a line has a y-intercept of negative 10 and passes through the point negative 6, 8. Write an equation of the line. Well, I always like to start these off by reminding myself the format that we write an equation of a line in. And I hope I've said it enough by now that you're really starting to remember it. But we know that this is going to be written in y equals mx plus b. And we remember that our slope is m, and our y-intercept is b, and x and y are any coordinate that fall on the line. So I always like to write over on the side, I know that I need a slope to do this, and I know that I need a y-intercept to do this. And I usually put a big box around these because once I have these two, that's all I need. But we know that I also have an x and a y if they're available and we need them. So let's look into our question here and see what information we can gather. So we need to get a slope and we need to get a y-intercept. Well, this says a line has a y-intercept of negative 10. Well, that's simple enough. We can just take that slope, or excuse me, we can just take that y-intercept of negative 10 and we can put it right here, negative 10. And it passes through the point negative 6, 8. Well, that's important information for us, negative 6, 8. Remember that a coordinate is written as x, comma, y, right? So negative 6 would be our x coordinate because it comes first. So I'm going to write negative 6 here. And 8 would be our y coordinate because it comes second. So I'm going to write 8 here. And then I'm going to erase this because we don't really need it. All right. So now I have to plug in what I have. And I'll color code this to make it easy. So we'll make our x in red. That's this one. We have our y in yellow. That's this one. And then we do not have a slope, which is blue, and we do have a y-intercept, which is green. So let's write our equation out with all the information that we have. So y equals, instead of y, I'm going to write 8 equals. Then I have m, which is the slope, which I don't have, so I just have to write m. And then I have an x, negative 6, and remember this is m times x, so I write this in parentheses. That way it's multiplication, and it's x is negative 6, so m times negative 6 plus b, And in this case, b is negative 10, so I could write plus negative 10, or I could just write minus 10, right? And now I'm going to solve for m. I have a one variable equation. Well, we can see here that I can take 8 and just bring it down. That equals m times negative 6. Well, m times negative 6 is just negative 6m, right? That's how we're used to seeing that written. And I have minus 10. And I really just have a two-step equation here. I have some subtraction I need to get rid of with minus 10, and I have some multiplication with the times negative 6 that I need to divide off. So remember, we always start with reverse order of operations. So we're going to get rid of the subtraction before the multiplication. We get rid of minus 10 by adding 10 to both sides. So I add 10 here, and I add 10 over here. That cancels out. 8 plus 10 is 18, and that's equal to negative 6m. Well, now I just need to divide off negative 6 to get m by itself. So divided by negative 6, if I do it to one side, I have to do it to the other. That cancels out. I'm left with m on the right. And on the left side of the equation, 18 divided by negative 6 is negative 3. So m is equal to negative 3. I'll put that up here for my slope, negative 3. And now I just need to go back. And remember, all I'm using are these two numbers. And I leave x and y just as variables, x and y. I just needed them to find that slope. So now I'm going to write my equation. Y equals mx plus b, so m is negative 3. And I just leave x as it is. And then b is negative 10, so I could write plus negative 10 or just minus 10. And there's my equation for this line that has a y-intercept of negative 10 and passed through the point negative 6, 8. Its equation would be y equals negative 3x minus 10. We can see that this line has a slope of negative 3, and it crosses the y-axis at negative 10. Let's do one more like this, and this time I'm going to give you the problem, and then I'm going to have you pause and try it on your own, and then you can check back with my work and see how you did on it. All right, so let's try this one. A line has a slope of 2 and passes through the point 1, 5. Write an equation of the line. Well, I'll remind you, again, I hope you're getting sick of me repeating it. That means you know it well by now. But this is written in the form of y equals mx plus b, where m is the slope and b is the y-intercept. We know that all we need is a slope. You could even write m to remind yourself. We need a slope m, and we need a y-intercept, which is b. And once we know these, we have everything we need to write the equation for the line. We also know that sometimes we need an x or a y if we're missing either a slope or a y-intercept. Well, let's take a look at this one. I want you to pause right now, and I want you to try this one on your own and take a look and see if you can find the equation for this line. So pause now and go ahead and try it. All right, I'm going to assume that you paused and you're back with me. Let's see what I get when I go through this one. So we know we need a slope. So I'm looking for a slope m, and it says here a line has a slope of 2. So I already have that answer, a slope of 2. And it passes through the point 1, 5. It doesn't mention anything about a y-intercept. So now I'm looking for an x and a y. And up here we have a point 1, 5. So remember, coordinates are written in x, y. So that gives me an x here, 1. And it gives me a y here of 5. I'll write that one in black. 5, just so it shows up better for you. So here now I have 3 of the 4 things between y, m, x, and b. And so I can isolate the variable b and solve the one variable equation for it. So here we go. Instead of y, I'm going to say 5 is equal to, instead of m, I'm going to write 2. And instead of x, I'm going to write 1, but I'm going to put it in parentheses because this is multiplication. It's not 21, right? It's 2 times 1. And then I'm going to add b, and I don't know what b is, so I just have to leave it here as b, right? Now I'm just going to solve. 5 equals 2 times 1 is 2 plus b. Well, I have to get b by itself, so I'm going to subtract 2 from both sides. That cancels out. 5 minus 2 is 3, which is equal to b. So b equals 3. I don't care about these anymore. Now I'm just going to write out the equation of my line using a slope of 2 and a y-intercept of 3. So my slope for my line, or my equation for my line is y equals, instead of m, I'm going to write 2x, and then instead of b, I'm going to write 3, positive 3, so I'll write plus 3. I have y equals 2x plus 3. We can see here really quickly, we can find our slope in it. We have a slope of 2, and we can find our y-intercept here, which is 3. So hopefully that's what you got as well, y equals 2x plus 3. And if you're feeling comfortable with this, you can go ahead and try your practice for today, where you'll be trying to find, taking an equation and finding the slope and the y-intercept, and that may involve turning those converting those equations into slope-intercept form, and then you'll have a chance to try a couple of problems like these last ones that we did, where you're given either a slope or a y-intercept and a coordinate, and you try to find the missing piece. And as always, please reach out if you have questions. We'll get help to you. All right, I'll see you in the next video. I somehow made a new page here.